Okay, hi everyone. Today I'm going to talk about micro-frontends. But before we jump to the exact topic, let me introduce myself. So my name is Oleksandr Khivrych. I'm a senior software engineer at Beamery. Beamery, by the way, is a lead talent lifecycle management in the world and one of the biggest growing startup in the UK. Talking about my experience, I have almost 9 years of experience in engineering. The interesting fact about me that over the last 4 years, I was trying and implemented actually micro-frontend concept in the various organizations. That's why I decided to share with you my experience and knowledge about this topic. And let's get started. So first of all, let's see what is micro-frontend, what's the definition of micro-frontends. So the same like with microservices, you can optimize your organization structure and can split your application by many parts, many independent smaller parts. For example, you have a front-end application like a website, and you can split it by a couple of different pages, which can be developed independently and owned by different teams. So the same concept like with the microservices, backend microservices. So initially they were created to optimize organization structure, right? And to be honest, it's also vaguely inspired and named after microservices. So the quick example is, for example, you have a web application, there is sign up page and profile page. And these two pages can be two independent micro application or microservices, whatever you call it. So I call it micro-frontends, actually. But yeah, using such an approach, you can achieve many benefits for your organization, for your product. First of all, it's an independent development. So teams are more focused on the subject areas and have a clear area of responsibilities. So again, like I said, each micro application, each part of your website can be owned by the different teams and developed independently. And it's a huge benefit because you will not depend on any other teams, and it's easy to understand the project as well. And together with these benefits, we have another one, independent deployment. So teams can develop independently some domain, but also can deploy independently some part of the front-end application as well. And another benefit is the short delivery cycle and incremental upgrades. So in this case, if you have working with the smallest part of the web application, like a micro app, your builds will be faster, tests will be faster, and it will be much easier to add new functionality and do bug fix eventually. And such approach also reduces the complexity. So for sure, imagine you have a new developer in your team, and for him, it will be much easier to understand the smaller parts instead of trying to understand the whole structure and logic of the big monolith. So he can provide the impact and start bringing some value, doing some tickets much faster with the micro-frontends. And another two benefits is isolating errors and more granular monitoring. So if you have micro application, there might be some isolated error boundary where will catch all the errors, while the rest of the application can be still running, which is cool. And granular monitoring and alerting will provide such benefits when we will see errors for specific team related to specific micro-frontend. And yeah, amazing benefits. They can bring a lot of positive impact for organization, for companies, for products. But one thing that I would like you pay attention is actually that microservices, backend microservices and micro-frontends, they're not completely the same. So in development, they are very similar. Different repositories or packages in mono-repositories, pretty similar CI/CD process. Like I said, dependent development, deployment, builds, different teams, exactly what we want, right? But at runtime, they're not similar at all because your backend microservices usually running where? In some other instances, in different servers, in different processes. If you're talking about Node.js service, it will be different Node.js process or a couple processes. But the browser one that we running our JavaScript code, it's a kind of monolithic environment where we have general event loop, shared document object, model with events, general address bar, navigation, local storage, session storage. All of this stuff is a global web API. So we need to accept that we can't go too further. We should try to achieve benefits from this part that we can have in development, but at runtime, it should act like a monolith, to be honest, because we are running our code in the monolithic environment. But sometimes people trying to go further, they're trying to do kind of sometimes over-engineering and do super independent micro-frontend. They're trying to create many abstraction over it. And because of maybe limitation of technologies, like I said, and maybe poor architected, they may also have a lot of risk while architecting micro-frontends. And let me pay attention of 5 of them, so that I found really critical one. So the first one is poor code sharing methods. Because sometimes when you're trying to implement micro-frontend architecture, you can forget about the performance. So then you sometimes can load duplicated code, don't use lazy load, or forget about the lazy load. That means that, for example, if you have profile application, you will load the whole bundle of profile application, even if you will not use this code, which will decrease your web vitals and your web performance will be not so great. Another problem, it might be divided our micro-frontends too finely. So what does it mean? So sometimes you're trying to split it too finely. For example, instead of have some domain micro-frontend or road micro-frontend or the feature, what is the best for organization? You can go too further and you can, instead of having one micro-frontend for the profile app, for instance, you can create 5 or 6, like for each small component, which is not really necessary. And in this case, instead of the updating only one component to be able to deploy to production, you have to update 6, which will eventually slow down your software delivery cycle. And that actually anti-pattern for micro-frontends, I think. So the next one is overcomplicated communication between micro-frontends. So it's an interesting part because when we deploy independently some parts, they want to isolate them as well, like I said with the error boundary. But the common solution is to have some event paths. You use, for example, the native browser events to communicate between the isolated parts. And sometimes it can be really overcomplicated and big cognitive load when you have 1,000 or 100 of the events, and it's difficult to track, and you need to provide the good documentation for it. And it also sometimes can slow down your development and provide big cognitive load for developers. So yeah, don't really like this one. So talking about other problems, these problems with the global libraries. When you have many micro-frontends, they're using the React library, for instance. And instead of loading only one instance of the React, you will load 5 or 6 many instances of the React, which will slow down your performance as well. And the final one is multi-framework support. Imagine you want to create micro-frontend architecture which will support Angular, React, Vue, all the frameworks that exist on the market, but usually it doesn't make a lot of sense, because it's also a huge hiring risk. Many product companies, startups, or the average companies, they trying to also, while interviewing the candidates, they're also asking questions about the technologies as well. And in this case, the person should know many frameworks and libraries. And this, again, it's a hiring risk. And usually it's a bad performance. If you have many different libraries for rendering for that application runtime, for sure your application performance will go down. And only one case is when you migrate from the legacy React application to the maybe Angular or other way around. Yeah, for sure you need to have some adapter to be able to support the multi-framework. But in this case, it doesn't make sense. But the question is there something we can follow by the industry to avoid such a problem and achieve micro-frontend benefits? And I found one solution. It's not exactly micro-frontends, but it provides a bit similar benefits. I call it modern monolith in monorepositories. So maybe you're familiar with tools such as Anix or TurboRepo or Next.js, for instance. All of them have a good structure, many features. For example, with Anix, you can create monorepository and bootstrap it and scaffold whatever you want. Like you can have set of the domains and split your application by the domains, have a different packages. And the same with the TurboRepo, which will provide you kind of independent development because you will have a separate model divide the separate model for each of the application. And it will still single React application if you're talking about React. It still will be a good web performance in independent development because each team will own specific model. Low level of complexity. And you can add also to this mono repository custom shared libraries, which will increase code sharing methods in your organization, right, in your team. But yeah, like I said, it's still monolith. It's not the micro frontend. It's just a modular monolith. You can read about NX through repo and this concept. But what I would say is you need to decide, do you really need micro frontend architecture? Or maybe modular monolith will enough for you? For instance, if you don't have many teams, why not just use modular monolith? But when you see okay, our organization growing and growing and more teams joining and start developing the same project, and we have pretty slow delivery cycle. So in this case, you would like to fix all of these problems with this structure. Sorry, could you someone mute, please? Yeah, so you try to fix all this problem related to this structure because it's still monolith. For example, no dependent builds, because if it's monolith, we build all the time the whole application, slow build process related to the same issue, problem with updating global dependencies, and no dependent deployment, which is really important. So we're thinking how I can improve my modular monolith and enable such a micro frontend approach. And I'm sorry, could you mute yourself or someone mute, please? Okay, nice. Super. So can we have super fast monolith at runtime? It will act like a monolith, but distributed the couple of front ends during the software delivery cycle. And yes, we can. There is some plugin in the industry, Webpack 5 plugin that will enable micro frontends and the modular monolith. It's a new killer feature in Webpack 5 that allows you to point in modules from another Webpack project, which will maybe install it on a different host. So what does it mean? It's exactly what we need. So for example, we have this modular mono repository with the different domains, whatever you split it, your front-end application. And by editing Webpack and modification plugin, from this point of time, you can do regular import, like ECMAScript import, but it will load chunks. It will load code from another host, for example, from another domain, another CDN, whatever you will set up your infrastructure. Exactly what we need. Before we jump to some demo that I would like to show you, I would like to go deeper to this topic. So with the model federation, each part will be separate build. So like I said, you have a many project in the model repository, you add the plugin to each of it, and then it will become container. And each container can be host or remote. So what does it mean? Host is when container consume modules from another container. Remote is the container who expose some modules. And but they can be host and remote simultaneously if they export some modules and import some modules from another container, another micro application, I would say. Another thing is container. We call it application when it's just entry point of our website. For example, if you have some core application which will load index.html and do some basic configuration, it will be we call it application. Okay, let's go a bit deeper. And I would like to say why is this model federation plugin is so cool? Because under the hood, this trigger, it's handled many complicated logic. For example, you would like to load some library, shared library, or some model from another container, from the container probably. So you're trying to imagine you have this work under the hood. So you're trying to load some model, I would say. You go always through the version check. Then you go to the share scope. So how does it work? So model federation at the hood, we'll see, okay, you're going to import profile page to render your another micro application. It will do all the needed version checks. Check, is it right in share scope or not? Okay, then it will go to container references. Container references from another container will respond to you with this model, put it to the share scope, the specific version, and then you load it like an ECMAScript model and everything will work, which is cool. And another killer feature, the same with the shared modules. For example, you're trying to load React.js, and it will also go to the shared scope, check the version of your React.js library, and then if everything is okay, it will respond from the container references and put it to the shared scope. And when you try to load stuff again, it will not do any HTTP requests, it just will load everything for the shared scope. Yeah, sounds quite complicated, but I decided to provide this diagram just to do some high-level overview of this technology. You can read a bit more about this, but let's go to the next slide. So just to talk a bit about the community. So it's important when you choose some technology for implementing micro-frontends to understand that it's used by the many big companies such as Netflix, Microsoft, Amazon. That means that it might be a good community in the industry. Something I would like to mention. So there are many cool names here, cool brands here as well. And this is the way that you can implement micro-frontends. But let's go to the real example, to federated React application. So I would say we have application that render two roles. First one is the orders page, where you can see the orders. And the second one is a dashboard page, where you can see the dashboard page. And the interesting thing, the dashboard page also render the recent order widget. So if you see this diagram, we have three micro applications. So the first one is a shell, a core application that handle all the global logic, like a layout, like a navigation, routing, maybe some infrastructure config, whatever. And this application exposes shell service model, where we can load and share some global configuration that needed for the another micro-frontends. And going to the another micro-frontends is the order container. So order container exposes two modules. So the first one is order service, which is just a separate page and where we render our orders. And the second one is orders recent widget for rendering this widget on the dashboard page. And this dashboard page is much simpler. It's also a micro application container which exposes just a dashboard page. And as you can see, to import each of the model, I just need to do regular sync import or async import. For example, when I need something from the shell, I do sync import shell/service. And when I need something from the order, for example, shell page need to render order page by specific role and the dashboard. I just do async import here as well. And the dashboard page also import some stuff from the orders app micro application, which will export recent order widget. So the interesting thing that all of this stuff handled by different teams. So team A owns the global core application, team B owns application order micro application, team C owns micro application related to dashboard logic. And here we see shared dependencies, something handled by model federation plugin internally. So the whole application using the only one instance of the global libraries. Sounds good, but let's go to the real demo, live demo, okay? So let me show you firstly, let me show you the real page. So this is the exact application that we was talking about. So I have a dashboard page and I have a orders page where this actually renders orders list, and the dashboard page currently renders only recent order from the another micro applications. And all of this navigation logic, when we need to render specific page by specific role, and the layouts as well, handled by the core shell application. Let's go to the code. Let's go to the code. So, like I said, we have a mono repository structure. Shared routing, it's our project. It's our, I would say, mono repository. And inside the shared logic, we have three different micro applications: dashboard, order, and shell. The interesting thing that each application, like I said, has Webpack config, and let's take a look on one of them. So the shell application has a specific Webpack config by building our JavaScript and all the needed stuff by Bubble. But the important part is what I was talking about. It's a modification plugin. We need to specify specific configuration. So we need to specify name of your container, of your micro application. We need to specify remote, like a file name remote entry. So it's kind of manifest for our federation micro application. Once we load the manifest, we know from which URL we need to load specific modulus. It's kind of modulus mapping under the hood. It's something that you don't need to pay attention a lot, but you need to, it's good to know. So the important part is remotes. So my shell application consume modulus from two other micro applications, dashboard and the order. Currently, because I'm running everything on my local machine, this one URL is hard-coded, but it may be dynamic. So there's some feature where you can do it dynamic. So you can say, okay, I would like to load some modulus from the order and dashboard containers from dynamic URL, which we can set up during the at runtime. This is important. And shell application basically expose shell service, some global configuration, some global stuff that we can reuse from any other micro-frontends. And the shell application itself is just a layout logic and routing logic as well. So as you can see, the shell application, it's a React component as well, which render some rows here from dashboard and order by specific path. And here we're using just regular React lazy and async import from Webpack, right? And to load those modulus, the same like you're doing in the monolith application. But let's go to another one. The same. Each application have a Webpack config and the modification plugin name, then remotes. We consume some global stuff from the shell. We expose two components from my micro application, the orders one, order service, which is the orders page, and the resource order widget, which needed for dashboard application. And the important part that also I would like to reuse shared dependencies. I don't want to load again them at runtime. I would like to use only one global version. So what I said it should be singleton and it should have the required version to prevent breaking changes. The same logic in the dashboard page, like a name, remotes, but in this case, dashboard consume modulus from the order, recent order widget, right? Shell, some global stuff from the shell, and also it's exposed dashboard page. And let's go to the dashboard code. It's just again, it's just a simple React component which renders something by a specific role, right? So it's just a React component, but it's also render recent order widget, which is from another micro frontend application. As you can see, we need to specify firstly name of our micro frontend application, then name of our model. Interesting. So let's go to the demo part. So I would say once we update our page, reload our page, we can see a couple requests. So like I said, initially our shell application need to load remote entry. And also we need to load a remote chunk from our application entry point, our shell application, then remote entry to be able to load each of the micro-frontend modulus if needed at runtime. And globally, we load all the shared dependencies, for example, material UI, React, and other stuff as well. And I also load, because currently I'm using here dashboard page, render here dashboard page and the recent order widget. That's why I load from the different URL at runtime, I load two different chunks, dashboard service and recent order widget. And when I go to the orders page, I don't do any other request because everything in shared scope already. I just load from the orders application, which is hosted on the different domain, different port, right? Orders page, which is a separate chunk. And when I go to the different pages, I don't do any other request because it's already in the shared scope. And the thing is, it's still single React DOM tree. It's a good web performance. It's still monolith at runtime, but during the software delivery cycle, you develop them independently, you build them independently, and you can expose statics from the different, I don't know, CDN paths and load them at runtime, which is provide you independent deployment. So you definitely need to build some infrastructure over it, but I think the monolith federation provide a huge benefits to do it right. And a few more things that I would like to wrap up. It's what about server side? So currently in the front-end industry, people start going back to the server side. What does it mean? You can render your page on the server side, the same React, for example. You render React components on the server side, then you return to the client the rendered HTML file and the get React. So that means that you not firstly download JavaScript files, then build virtual DOM on React, then build a real DOM tree. So you immediately have all of these document nodes from the initial load of the index.html file. And when we're talking about server side, I think one of the best and the popular framework for the server side React framework, it's actually Next.js. There is also Remix as well, but let's talk about Next.js. And recently, Zach Jackson, who is the creator of this Modular federation plugin, he said, okay, we're going to develop version of this plugin for the Next.js. And that's why I would like to show you another quick demo of the server-side rendering. So in this case, you have a mono repository. You have mono repository with the three apps, micro apps. It's a home, it's a shop micro app, and checkout micro application. To provide more, okay. Anyway, so yeah, you have three different micro applications for the server side, right? Shop, home, and checkout. And each of these applications are different Next.js application. So if you whenever work with the Next.js, it's React framework. And you can control everything using the Next.js.config file. And exactly in this file, we can do the same magic. We can add Next.js federation plugin. We specify the same configuration that we did previously in another example that I shared with you for the client-side rendering, but in this case, it's a server-side rendering. So again, for example, for checkout page, we specify name, we specify our remote entry, and what this page exposes. Currently, it's a checkout page and some component, kind of title, which is some React component. On the home page, we're also using this plugin, the same basic configuration, and the same actually for the shop page. So shop page exposes shop page eventually, few components as well. And you run and develop those parts completely independently. And I'm going to show you the live demo. Let me, yeah, so this application that I was showing you, the code of this application. So when I open my DevTools here and refresh the page, I see that initial request is my index. Let me try again. My index HTML is actually already pre-rendered. So that means that all of this logic rendered on the server side, exactly what we need. But the interesting part that this part is from checkout page, right? This layout part from the home page. Oh, sorry, from the home application, right? Which is eventually, we see it's a micro-frontend as well. But server-side works perfectly. But when you go at, yeah, let's try again. When you go to the shop page, for instance, let me try again, I will show you the network. When you go to the shop page, from this point, client-side rendering works well, and the Modular federation client-side rendering works the same. It's just load one chunk from the different application host on different port and render shop page. But when we refresh the page, everything pre-rendered on the server side as well. So everything works perfect. We go to checkout page, the same. Client-side rendering works well. We load all necessary chunks. And we even load some data from the Next.js as well. We're using get initial props. We can use get props from the server side as well, if you're familiar with Next.js. But when we update the page, everything rendered on the, let me try again, everything rendered on the server. And how does it work? So it's basically load all this chunk, federated chunk on the server, build the HTML page and return it to the client. And then we load all necessary JavaScript code to be able to hydrate this React application, and then all magic happens. We go from the different pages and it will load only those chunks that you needed. But when we go back, it will not load anything because it's right in the shared scope. And again, at runtime is the simple single React tree. And yeah, exactly what we need. Our micro-frontends works well at runtime, acting like a monolith, but during software delivery cycle, it's a micro-frontends. Exactly what we need. And basically that's all. Let me continue my presentation. I would say thank you guys for your attention. And you can see on the screen my Twitter account and also my link to my personal blog as well. One more thing that I would like to say, that it's just a high-level overview. It's just one solution that you can use for building micro-frontends. But I would say after a couple of years, it can be a bit different libraries in the industry. But the interesting fact that you need to understand, do you need this for your organization? How are you going to build infrastructure for it? And I would say prevent all the mistakes and risks as well. Before we jump to the questions, I would like to share with you exciting news. Like I said, we work in, I'm a senior software engineer at Beamery, and the Beamery has introduced the coding challenge. So how does it work? You scan this QR code, and then it will open the page where you can try to participate to our coding challenge. Usually this coding challenge may take not more than 30 minutes, depends on your level, right? And the best, I don't know, the best result of this coding challenge and the best participant will have a chance to win MacBook Air M2, which is cool. It's another thing. And another benefit, it may be super quick, smooth interview process with Beamery. So just try to scan this QR code and yeah, you can try to participate. Okay, that's all, guys. I'm going to answer all of your questions.
Yeah, thank you so much for this presentation. If you wish, I can read out the question so it's more moderated. So yeah, we've got a bunch of questions, so clearly people were very interested. Okay, so there was a clarification when you referred to containers, you meant Docker containers, right? Or something else?
No, I don't know. It's the model federation terminology. So okay. It's how this architecture works under the hood of this model federation plugin, but it's not related to the Docker. We don't need Docker for client-side rendering. We just need to have some chunks from CDN, right? Container is, I would say, it's a Webpack project, right? Federated Webpack project that has model federation plugin. And this container, or we can call it micro application, can expose some modulars for another micro applications. That's all. It's not a Docker container.
Got it. Let us know, Gunnar, who asked the question, if it made sense or we should clarify. There was another question from Nilima. Is module equals to standalone feature? Does module equal standalone features being in their repos as well? I'm not sure I understand this question. If Sasha, you do, we can answer, or we can ask Nilima to clarify.
Yeah, I would ask to clarify, please.
Okay, yeah. Go ahead to clarify. If you want, you can also ask it in voice. So or write in the chat.
Sure.
William, go ahead.
Curious to know, like, the modules. By that, do you mean like each module will be there in its own repository, and then you use something like a Lambda service or something to execute your modules on the side, and that's where the micro front end thing is coming up? So it was asking from that perspective.
Okay, I got it. Thank you for your question. So the answer is depends what is your strategy. If you're going to use server-side rendering, so yes, it can be a separate Lambda where you load those models from another micro application, maybe from another Lambda, or it depends what is set up of your infrastructure, right? But when we're talking about the only client-side rendering, you don't need a Lambda, you don't need anything. You just need a CDN. In most cases, you need the CDN that you upload your, for instance, each model. Let me show my screen. So if you're talking about client-side rendering, each model inside the mono repository, right? Each mono repository project is a micro application. We can also call it a container or micro frontend, whatever you want. And it will expose some JavaScript modules actually, which may be React component or whatever you put there, right? And when you build your application, this build for sure will be independent because it's two different Webpack projects, right? And you can deploy them to CDN, for example, to the different paths. It can be application name, then version, and then you can easily switch between the versions. Yeah, we're talking about the client-side rendering. About the server side, probably the same, but because you may have some logic, you just need to deploy different Next.js application. It can be Kubernetes cluster and the Node.js services, or it may be just, if you're using Vercel, it may be different Vercel instances, like also H function, whatever you need. You can easily deploy Next.js application in the Vercel, or again, Lambda for sure. Like this answer.
Okay, thank you.
Thank you for the answer and the question. There was another one. Can you combine different frameworks?
Different frameworks. First of all, if you're talking about the React is not a framework, it's a library. But I can compare, for example, it's to be honest, it's a really difficult one to compare because most of the frameworks has pretty good performance, right? If we're talking about micro-frontend approach, for sure, React is a library, but it's a pretty flexible library that you can build your own infrastructure and build your own framework in the end, right? For example, with the Angular.js, you have a specific bootstrapped application, which you have services, roles, and all the more clear architecture for sure, using the object-oriented paradigm. And yeah, it may speed up the process of development because you already have some structure, but it might not be so flexible. But in most cases, you need to understand what you'd like work with. You will not see the huge performance difference right now with the Vue, React, Angular, I think. If you write the high quality code, what do you like, what your organization focused on initially, what's the community, you need to choose the community of this project. Maybe something new, like I guess the new one is is kind of lightweight React or something. Do you need server-side or not? Again, if you need server-side, maybe use Next.js with Remix. I like more Remix actually, but in the Next.js 13, for instance, there is a server-side streaming feature, which is cool, and it might be an interesting option as well. So it depends, again, depends on the community hiring and what you like work with, actually. That's all. It's difficult to say this framework better or not. Like React probably is the most popular right now. So I like React. It's because it's flexible library. They can build your infrastructure, and there are many. It's popular. It's much easier to hire and found React developers as well. So this is my point of view.
Yeah, thank you. As always, the answer is it depends. So there was another question from Gunay about handling errors. So how to handle if there is how to handle if there is any load error, like module loading errors.
If you open Modular Federation documentation, there are a few examples, but I guess yeah, you can. There is few examples where you can catch an error when you loading of your import was unsuccessful and log it. It will be difficult to me to find exact the page in the documentation. I can send it later, but actually you can just use some try catch functionality. You know, you can use React error boundary to catch this error in the specific micro frontend and then log it to the Sentry. That's all. So, for example, if you have a like profile application and you want to render something from the other micro frontend, but the whole profile application wrapped in the error boundary, and when it was some error in the import, you can catch it, like a try catch functionality. Or if it's the problem is this exact small application, another micro-frontend, we can catch it there. Like like regular error boundary, error boundary try catch. And if you go to the Modular version documentation, you can see there's few options that you can handle errors if you have a failed imports. Yeah.
Thank you. We also had a question about SSG. Is there SSG support? And SSG stands for, I just Googled, static site generation. Is that right?
Yeah. So
or is it it's something else?
Yeah, it's static site generation with the Next.js. Talking about this model federation on Next.js, it's actually interesting because I would say it's a beta, and I wouldn't use it to production with the Next.js, but with the client-side rendering, with the React, or like any Webpack project, definitely will use it. It's bullet tested. But talk about the Next.js, it's actually something new, something in beta. We need to wait how it will be supported by community as well. But the idea is definitely will be followed by community, and maybe it will be something else in the future, or they might finish this development. It's one thing. The second thing regarding static site generation, I think it will work. It definitely will work. I guess static site generation will do requests when you build, it's invoked when you build your application, right? And again, you upload everything to the CDN. And then you can invalidate the cache, do some logic, and upload it to CDN again. So Modular federation can load chunks to the CDN, and it will work, definitely, for sure.
Cool, thank you. There was a follow-up on the question about loading errors. Can you set timeout limits, and how might you alert on module load failures, assuming server-side rendering?
Yes, so you can use probably, if you're talking about server-side rendering, yeah, again, you do some import, you can use some, again, it's kind of simple try catch stuff to catch the error. If like it's basically under hood is the promise, so you can do the catch chain and then log it. It's not the problem. Do some wrapper, but I recommend also go to the Next.js SMF plugin and take a look on the documentation. It might be some examples about it, because I never used it in production. I mean the Next.js plugin. Another thing. Regarding the performance and timeouts, for sure it might be some latency, but if it's every service running in the same cluster, it might be pretty fast to load them by HTTP. But also you can use HTTP streams, right, and load kind of by chunks as well, which will speed up things. Yeah, this is an answer.
Cool.
One thing regarding security. So again, the server side code should be like inside some network, which is private network, right? That you can load all the chunks inside your cluster, maybe hidden by some VPN, whatever. So there is some security gap that you need to pay attention. So you can't expose these chunks that has the server-side logic. For example, if it's connected to the DB and get some data, then render it to the page on the server side, you can't expose this code to the client anyway. You should have some guards, and it should be some private route in your network, like in your cluster, right? Maybe you can encrypt it as well if needed. So this will a bit improve security.
Great, thank you. Thank you for those tips as well. So there was another question. Is there a way to combine NX with module federation? If yes, what will the result look like? And also, if you can clarify what is meant by NX for those who are not familiar. Do you know, Sasha, what is meant by NX? You're muted, I think.
Yeah, for sure. Sorry, I was muted. So let me open the screen. Next, I'm going to show you example with NX. It's a good question, and definitely I really like NX because it can speed up mono repository. It has some cool tools, and caching is amazing one. parallel caching, parallel execution, and the cloud caching is cool. So there is some official example in the NRWL organization who is currently contributors, and they support NX, main contributors to NX. There is an example with Model Federation React, for instance. And as you can see, there are also like micro applications, besides the end-to-end for them as well. And yeah, it's fully on NX. And the thing is, NX kind of said, okay, you didn't change anything in other micro application. That means that we need to build only this one, save it to some cache, and then the process will be much faster. So your build pipeline will be much faster. To be honest, if you're not familiar with Model Federation on the client side, I'm going to send you my article as well. I'm going to send you my article to the chat, so you can read more about it. There's a few diagrams, useful links, code examples as well. Yeah, and mostly you can also follow our Vimri blog. You can go to the previous article about the retrospective of using micro-frontends concept as well. Yeah.
Thank you for that. We have maybe 1 minute for the last one. Just a short answer, maybe. Can we work with 2 different versions of React, like one with less than React 16 and one with the latest version? Will we end up with any issues while we expose one service and consume it in another latest version of React? Just curious to know. So if you can give like a very short answer to that.
Yes. So yes, you can have many versions of React. It depends. So it depends of your architecture. I personally like when you have only single React DOM tree, and you just import React component from the different micro application. But it's also possible to create some kind of adapter when you need to support legacy version, or you migrate from Angular to React, for instance. That means that you can have a 2 separate React DOM tree or another Angular DOM tree, right? It will use Webpack as well for build and Model Federation plugin. That means that at runtime you will have many React version and the different React trees. So it's definitely possible. And sometimes when you can't update easily to the latest React version, you definitely need to do it. You definitely need to have some adapter to have a few React DOM tree at runtime, or maybe Angular as well when you migrate from the Angular, right? But the thing is, I don't really like this approach. Why? Because when you have technical devs, usually we don't pay a lot of attention on it. And we said like, okay, Tim, we need to definitely migrate to the latest version of the React. And if you will have such a possibility to create such adapters to have many React DOM tree at runtime, that means that we will never migrate to the latest React. So I personally like to put like a singleton, React-based context libraries and React DOM tree and React DOM and React, and use GitHub code mode, for example, for updating. It's globally once. That means that everyone still has independent development, deployment, and all these benefits, but they always up to date. And they always up to date. They have a good performance, good developer experience. If you said, okay, we have this tool where you can have a legacy version of React, they definitely will not update it to the latest version in the future. Like these tech devs will be with them for many years. This is my opinion. And yeah, this is an answer. But regarding the other libraries, for example, if it's not related to React or not some context libraries like React Router, for instance, for example, using the Lambda or Lodash or whatever library you use, it will be still one instance at runtime. If you go into update to another version, you can specify a version and it will be two instances at runtime. You will not load 10 or 15 instances, only 2 until you migrate fully to the latest version. So it's kind of benefits as well. This is an answer.
Got it. Thank you. Maybe one last question. We're out of time, but maybe super quick. Can you have one app in Next and then one in Angular with Modular Federation?
Yes, for sure. So again, Model Federation plugin is just a tool. So for example, React is also just a library. It's not a framework. So you can use this library in many ways, build any structure of your project that's pretty flexible for specific organization, etc. The same as Model Federation. It can enable you to build independently your container micro apps, expose and consume modulus, but what inside modulus is up to you. So we can say, okay, I have two separate application, micro application. First one is based on React. It's expose few components or few pages, but it's also do this all the magic that mount React DOM 3 under the hood. And another one is the Angular based that have singleton version of the Angular, like a shard dependency in the modification plugin, expose few components, but under the hood is also mount application to specific DOM 3. Yeah, like a document object model. That's all. I mean, it's how you write your code inside your modulus. You can have such a wrapper and use model federation for the performance aspects to have this code split at runtime. You don't load modulus that you currently not using at runtime, and use shared global dependencies only once at runtime as well. Like for performance optimization, it's a good option for now, I think.
Thank you so much for the answer, for sharing the context. Yeah, overall, thank you so much for this conversation, this chat. I think it was very useful for all of our guests. Thank you, everybody, for asking the questions as well, and for being here, for sticking around until the end. I shared the link in the chat for you to follow Sash if you're interested in learning more about the field of micro frontends, and also a link to join us, to join Women Who Code. There are various ways to contribute and be part of this organization. I hope you enjoyed it, and I hope you have a lovely rest of your day or evening. That's it from us. Thank you so much. Bye.
Thank you.